Matrix A is defined as A is equal to 4, 6, 3, and 5. Find the following, A inverse. Now, how can we find A inverse? Here's the formula. A inverse is equal to 1 over the determinant of A multiplied by the adjoint, which basically means that we have to switch A and D, and we have to negate this entry and negate that entry. Now, what is the determinant? The determinant is A times D minus BC. So 1 over the determinant multiplied by the adjoint. And so let's find, or let's determine first the determinant of A. Now, what is the determinant of A? Well, the determinant of A, in order to find it, we have to do A times D minus B times C. What does that mean? We multiply 4 times 5, right? Multiply 4 times 5, 4 times 5, and we subtract it with 3 times 6, all right? Now, what is 4 times 5? 4 times 5 is definitely 20, and 3 times 6 is 18. So that means the determinant of A is 20 minus 18, which is 2. So the determinant of A is 2. Now, what is the inverse of A? Well, the inverse of A is going to be equal to 1 over the determinant of A. I mean, the determinant of A is 2, multiplied by the adjoint. What does that mean? That means that we have to switch, right? We have to switch. So imagine you have matrix A defined in the following way. Imagine if you have matrix A as A, B, C, and D. And that's matrix A. So what the formula is telling us, if you notice carefully, it says that we must put A here and D here. So if we originally had A, B, C, and D, if we want to figure out what is the adjoint, or what is this matrix, what we have to do is we have to switch these two entries. So instead of putting A here, we put A here, and D goes here. So we switch these two entries, and the next thing that we do is we negate the C and we negate the B, and that's the idea. So if we go here in this matrix, we have to switch 4 and 5, which we did. 5 is here, 4 is here. And then we have negate the 3, which we did, and negate the 6, which we did. And so this matrix is good. Now we have to multiply this matrix by 1 over the determinant of A. And we know that the determinant of A is 2, which we found out here. So A inverse is equal to 1 over 2 multiplied by this matrix. Now we're going to take 1 over 2, or half, and multiply it by each term, or each entry in this matrix. And so we have 1 over 2 multiplied by 5, which gives us 5 over 2. 1 over 2 multiplied by negative 6 gives us negative 6 over 2. 1 over 2 multiplied by negative 3 gives us negative 3 over 2. And 1 over 2 multiplied by 4 gives us 4 over 2. Next, we simplify. We keep 5 over 2 as follows. Negative 6 divided by 2 is in negative 3. And we keep negative 3 over 2. Now 4 divided by 2 is definitely 2. And so this matrix is the inverse of A. And that's the answer to our question.